Hello, welcome to the FLL programming training. So first of all, I would like to thank you for attending this programming training. It's gonna be a lot of fun. You're gonna learn a lot. My name is Ryan Belknap, and my co-presenter is Victoria Kirk.
Hello.
And we will be presenting programming and explaining it to you guys today. So the first subject we're gonna go over is what is programming? So during this process, while I go over what's programming, I'd really appreciate if you guys can unmute yourself or raise your hand and answer the questions that I'm going to be asking throughout this presentation. So first of all, how many of you guys in this call right now can speak a language? Just raise your hand in Zoom, or you can unmute yourself. All right, we have a couple people who can speak a language. That is terrific. Okay, you can now lower your hand if you can speak a language. Now, how many of you guys have ever had a conversation before? Really? None of you guys had a conversation before? Okay. Well, okay, yeah, a lot of people have had conversations before. It just took a second. For those of you who have had a conversation, what really is a conversation? Does anyone want to unmute and explain what a conversation is? It's okay if you don't. So a conversation really is, in its simplest form, is when I talk to somebody else or you talk to somebody else. For example, watch this. Hello, Victoria. My name is Ryan.
Hello, Ryan. My name is Victoria.
And bam, just like that, we have had a conversation. It's just that easy. Now, how might I, a human, have a conversation with a robot? Does anyone want to try and reply to that? How do you think I might have a conversation with a computer or a robot?
By talking to the robot.
Yeah, so that's a conversation. That type of conversation where I talk to my robot is called programming. Has anyone ever heard of programming before? You can raise your hand if you want. That's absolutely fine. Okay, that's perfect. Okay, you may now lower your hand. Yeah, so programming is a conversation. However, it's not really a normal conversation. Instead of sounding like a conversation where I might ask somebody, how are you doing? And they might respond, oh, I'm doing fine. This conversation is going to be more like a list where it's a bunch of steps. For example, our list might consist of stop or go forward, start, a bunch of those things in order. So that would sound more like start, go forward, and stop. Can somebody give me an example of a bunch of lists or a bunch of things that might consist or make up a list? Does anyone want to unmute to explain what a list is? All right, that's fine. We can go on. As I mentioned, a list that you might use to talk to your robot with is start, move forward, and stop. Of course, your robot's probably not going to understand that list as it is currently, but that's fine. When we start, it'd be weird if we started talking to you guys in a different language. Some of you guys might understand what we're saying, but for the most part, you guys might not even know what we're trying to express, what we're trying to tell you, because we're not speaking the same language. Our robots are very similar. If I started speaking to a robot and I yelled at it to move forward, it's not going to simply start moving. Programming requires us to work on a computer to communicate with our robots. We have to speak their language, speak the robot's language, to be able to have a conversation with it. Does that make sense to everyone? Okay, so now that we've gone over what is programming, let's go over something called pseudocode. Before we go into explaining what our actual programs are, we need to first explain how you should go about making the rubric for your code to before you even power on your computer to begin programming. An outline, as you see on the screen, is it's a list really of things you want to do, things you want your robot to do, and you want to program your robot. This type of outline includes the steps that we will eventually use to program our robot. However, it's not the actual code for the robot. It's not the code you'd see to program a robot. Once again, it's just a list of what we really want to include in our robot's program or list of programs. This makes it sure that we don't skip any steps in the process of achieving a mission, and that every aspect of what we want to achieve is accomplished. In other words, this outline will make sure that no steps are absolutely no steps are skipped in this process. It's really effective, and we suggest using it, making a list before you even power on your computer. Is anyone confused by this idea? Okay, now we're going to move on to a more technical example. So now we're just going to go over a quick demonstration of how you want to download and open up EV3 Lego Mindstorms. Here I am on the right side of your screen. And this is the website you should go to download your program to begin coding your robot. You can simply find this. It's very easy to find. You can find this website by typing in EV3 Lego Mindstorms. It's usually the top result, and it should look something like this, where you can see what it looks like usually to program on a device. However, we're going to scroll down a little bit to where we see EV3 Software for PC. If you're on a Chromebook, of course, you're going to want to install it on the version of your Chromebook, and usually it's an app, so you'd want to go to the App Store or Google Play. If you're on an iPad, you'd want to go to the App Store. But yeah, they have all the different downloads you need here. The one I typically use is the EV3 Software for PC. And now that we've done that, we can exit out of that tab. And here's my background. Luckily, I've already installed EV3 Lego Mindstorms, and here it is on my desktop at the summit of this mountain. Now, if I double click on that, and we patiently wait a second, this screen will pop up. And wow, that's a lot to take in. That's a bunch of colors, a bunch of robots, but it's really cool. So the most important thing if you've gotten to this step, if any of you guys have ever seen this, you know that this is essentially the main menu for EV3 Lego Mindstorms, which is the main menu of where you'll start the program. The first thing we're going to want to do today, however, is in the upper left-hand corner. If we want to make a new program, we're going to click the arrow, or sorry, the plus sign, which is Add Project. You guys can see my cursor. I've just added a new project, and after a second, bam, just like that, that's our new project. That's our brand new project. Now, for the sake of being able to save it, we're going to explain that now. Once again, in the upper left-hand corner, we're going to want to hit File, and then under File, you're going to want to hit Save Project. And once you do that, this File Explorer tab is going to pop open, and you're going to be able to select where and what you want to name it. So where you want to save it, and then what you want to name it. So for the example of this, I'm going to say Demonstration 3, because I've already done Demonstration 2. And if I hit save, it should disappear, and bam, just like that. Change the name up here. You can tell that you've saved it because Demonstration 3 project has changed from project to being Demonstration 3 in the upper left-hand corner. And you always want to go back to here to save it, or use the hotkey to save it. But yeah, once again, you want to open it up on your desktop, and then you want to navigate to File, or sorry, the plus first to open a new program. And then to save what you've worked on using these blocks down here, you're going to want to hit File and then Save, and name it whatever you want, and save it wherever you want. All right, that's basically how you work with the EV3 Lego Mindstorms software. Now that we've done that, we're going to continue back to our before we go back to our presentation, we're going to see a quick core value video by one of our team members. Julian made a core values video about teamwork, and we're going to watch that really quick.
What about me? Make sure everyone is working and not just playing around. Once everyone's incorporated, productivity will astound.
All right, thank you, Julian, for that quick demonstration of what teamwork does for our team in terms of core values. And now, before we continue back to our presentation, once again, we're going to go over a quick straight line demonstration that was done by one of our own students. Once before I start, I'd like to thank Reese for making this video, and here it is. All right, that was a rather quick video. Of course, that's one of the first programs your team is probably going to end up designing. However, he also explains the pseudocode for it, which is the list, the outline you're going to make for your robot. Here he is explaining.
This is the pseudocode for programming a straight line. The first step for programming a robot to drive in a straight line is to find a consistent starting spot for your robot. You can use a jig to help find your starting spot. The second step is to measure the distance between the robot and where you want your robot to end up. The third step is to make the code. You can make the code by adding a move tank block in your programming software and downloading it to your robot. The fourth step is to adjust the distance the robot drives by increasing or decreasing the number of rotations in the move tank block.
All right, thank you, Reese, for explaining how he planned out his straight line demonstration. And then the second step in his process would be programming it. So he's already made his list, and now he's going to end up programming it. And this is what this video is.
To program your robot to go in a straight line, you need to add a move tank block, which is located in the middle bottom of the screen. Then you need to change the number of rotations to the number of rotations you think the wheels will take to get to your destination. Then you need to download the program onto your robot and test it out. The download button is located in the bottom right of the screen. After you test the robot, you can change the number of rotations and download the program again until the robot goes the correct distance.
All right, thank you for explaining that, Reese. And once again, we're just going to show his video of how his list and his code ended up making this program right here. And although it looks simple off the bat, it's actually not really that easy to program. Programming a simple line is one of the first things you and your team should do, but it's definitely takes planning and a lot of thinking behind your robot code and your pseudocode to have a successful straight line diagram. And now to explain the different types of turns, we have Victoria, and I will transition back to the PowerPoint for her to explain that.
Thank you, Ryan. So once you have analyzed the game field and figured out the path that your robot will have to take, you will need to choose what kind of turns you will use. Does anyone know the 3 different turns that a robot can make? Would anyone like to speak up and share any ideas? Okay, well, the 3 types of turns are the tank turn, the pivot turn, and the drive turn. In a tank turn, both wheels will turn at the same speed, but in opposite directions. This causes the robot to turn in place around its center of mass. This turn is very useful when the robot has to maneuver in a tight place, like between 2 obstacles on the field. For the pivot turn, one motor does not move while the other does. In other words, one wheel will have a speed of 0 and the other will have either a negative or a positive speed. Therefore, the robot turns, or pivots, around one wheel. This turn has a wider radius and takes up more space than the tank turn. It can be useful when the robot has to round a bend. In the drive turn, both motors go the same direction. This way, the robot keeps moving forward or backward while it is turning, making a very wide but efficient turn. This is also how your car turns. Since this turn takes up so much space, it is used when there is plenty of area to turn in. The larger the difference between the speeds of the 2 motors, the tighter the turn will be. I'll turn it back over to Ryan now.
Thank you very much. That was a wonderful job of explaining those. And to see a quick video of what those look like, Miles, another one of our students, has made a video explaining and demonstrating all 3. So here that is now.
3 ways to turn a robot. The first way is a tank turn, which is a turn about a point between the 2 powered wheels. You can program a tank turn using a move tank block with one wheel set to negative power and one wheel set to positive power. The second way is a pivot turn, which is a turn about the wheel that is not being powered. You can program a pivot turn using a move tank block with one wheel powered and one wheel set to no power. The final way is a driving turn, which is a turn about a point outside the robot. You can program a driving turn using a move tank block with both wheels powered in the same direction at a different speed.
All right, thank you, Miles, for explaining the 3 different types of turns, or demonstrating rather the 3 different types of turns. Next, we're going to go over the 2 main motor blocks that we're going to focus on today. The first of which is the medium motor. The medium motor, as you can see by the left, the green block, is a motor. It runs the motor at a set speed for a set amount of rotations, seconds, or degrees. The speed can be adjusted to run the motor counterclockwise or clockwise. Now, if anyone's taking notes, which we recommend, we have some important things that you guys should remember about this specific block, about the blocks we're going to go over. For this specific block, however, the important things to remember is that the large motor utilizes only one motor. It only controls one motor. The speed can be set from a negative 100 to positive 100. So once again, that would dictate whether you'd be going clockwise or counterclockwise. And finally, this motor can run for a number of seconds, degrees, or rotations. And now we are going to move over to our second motor block, which is the large motor. The large motor runs a motor at a set speed for a set amount of rotations, seconds, or degrees. The speed can be adjusted from the motor clockwise as well as counterclockwise. And once again, some very similar things to remember about this block is that the large motor utilizes a single motor. It can only control one motor at a time. The speed within this motor block can be set from negative 100 to positive 100, which once again is how you'd go clockwise or counterclockwise. And finally, the last and most important thing to remember is that the motor can run, this can run the motor at a number of seconds, degrees, or rotations. And now we're going to draw some similarities between the large motor and the medium motor, since we've gone over both of those just now. There's a lot of similarity between these motors, as you guys hopefully have noticed. The large motor and the medium motor are essentially equal in the program. However, each motor is physically different. You can program them about the same way. In other words, you can program a large motor to do the same amount of rotations, the same amount of speed as you could a medium motor, which is really cool and really quite simple. Now, before we move on, we're going to get another core values, video from our Julian, another member on our team, talking to us about inspiration. And here she is doing that.
I can't understand this. Help your teammates solve problems. If you can't figure it out, bring in someone else or do some research to learn more about it.
All right. Thank you, Julian. She did a great job going over inspiration and core values and why it's important. Next, we will be going over the two movement blocks. The first of which is the move tank block. This block controls two motors for tightly turning a robot. Wheel speed can be adjusted independently, as can turn length, which is really, really cool. This is the first time we're going to see this type of block do two things at once. And once again, if you're taking notes, some important things to remember. This block can control two motors at once. The direction can change from negative 100 to positive 100. That's how you turn counterclockwise or clockwise. And through this block, you can set one motor at a different speed from the other for a certain amount of seconds, degrees, or rotations. Right, and our next movement block that we're going to go over is the move steering block. This is a specialized block for that is used for smooth turning of a robot. The angle could be adjusted as well as the measure of how long it should turn for within this block, how long your robot should turn for. Some important things to remember, just in case you're taking notes. This block controls two motors at once, similar to the the move turn block that we just saw. The move tank block that we just saw. Both can control two motors at once. Once again, the direction can be changed from negative 100 to positive 100. And this block controls two motors for a number of seconds, degrees, or rotations. Now, the next thing we're going to go into is the weight block, which is the first thing in our flow control series. As you've noticed, as you probably noticed on your screen, that the block is no longer green, it is now orange. We've gone out of the movement section of blocks and we've gone into the flow control section of blocks. So this isn't actually control motor, but it does help you program your motors to do certain things. So this is still very, very useful. What the weight block is that it serves as a introduction. It introduces a gap between one task and the next. In other words, it pauses the program for you. So you can pause the program for an amount of seconds. You can wait for 10 seconds, or you can pause it for a certain amount of sensor input. For example, if you get too close to a wall, you can use this block to determine the distance between the wall and your robot or your ultrasonic sensor. And just some important things to remember is that the weight block can be configured to use primarily time or sensor values. And as I mentioned earlier, just a second ago, an example of this is the weight block can pause the program for 10 seconds, which is really, really cool. Another example of what the weight block can do is that it can pause the program when the ultrasonic sensor detects less than 4 centimeters. And that would prevent your robot from hitting a wall or hitting an obstacle, which is very, very important. And now, since we've learned a lot about different types of blocks, movement blocks, and our first flow control block, we're going to go into a medium motor demonstration video, and that should start right now.
All right, hey guys, this is Mr. Zare here at Landrum Middle School. Today we're going to take a look at programming the medium motor for the LEGO Mindstorms EV3 robot. Before we do anything though, I just want to remind you, make sure you're always using your brain. Make sure you think things through. It makes life a whole lot easier if you do that. So here we have our programming window. It's already open. I have a blank project, blank program. And when it comes to the medium motor, it's extremely similar to the large motor. It's pretty much exactly the same, but we only have one programming block that deals with the medium motor, and that is this one right here. Okay, so I'm going to take this programming block and I'm going to drag and drop it and connect it to my start button or my start programming block. Before I do anything else though, I want to make sure that I save this file. So I'm going to go to File, Save Project As, and you can see I already saved a project here before with this name. So I'm just going to use that same name, Medium Motor Project. I've saved this to my desktop to make my life a little bit easier to find it. So I'm happy with that. I'm going to click Save. Yes, I'll go ahead and replace that. Now, once we get to this programming block, first thing I want to always check is I want to check the port. On my robot that I built, my basic Lego robot, my port A is reserved specifically for the medium motor, so I'd make sure that that is correct. If it's not correct, I would go through and change it to whichever port I've got it connected to. Once I've done that, we can take a look at the different options. I have an option for off, on for seconds, on for degrees, on for rotations. Any of those are going to be helpful to you. It just depends on what you're comfortable with. Remember, if you just turn it on and leave it on, it will not run unless there is some point in your programming that causes it to turn off. So if you just leave it on forever, you download your program just won't run. Okay, so I'm just going to leave it on for rotations. Okay, and the next thing that we have is speed. And this particular motor is connected to my front kind of forklift claw action type of device. So I don't want my speed to be very high. I'm going to drop my speed to maybe, let's say 18, sounds good. And the number of rotations just tells me, you know, how many times it's going to spin 100 degrees around. And the way this sets up is one whole rotation will cause my claw to really move a lot. So I'm going to decrease this to like a quarter of a rotation, which would be 0.25. Now, again, I have the same options, brake and coast, so I'm just going to keep that as it is. Now, I'm assuming that a positive speed will make my claw go up. I'm assuming that a positive speed will make my claw go up. So in this program, what I want my claw to do is to go up, and then I'm going to add in a time wait, and then I want it to go back down. So let's add in something that we haven't taken a look at yet. I'm going to go to my flow control, which is the orange tab, and I'm going to find the wait programming block. And I'm only going to use the most basic part of the wait programming block, which is time. If I actually click on this, you can see that there are tons of options here. but I'm only going to stick with time, and I'm going to make the wait 3 seconds. Okay, and after it waits 3 seconds, my claw should go up, wait 3 seconds, and then I want it to do the reverse of that. So I could go back to my action tab and simply drag another one, or I could simply select this one, hit Control, copy or C, and then hit Control Paste, and I simply drag that over there. So the way that I did that was Control C for copy and Control V for paste. Now, the only difference between the first programming block and the last programming block is that I don't want it to go in a positive direction. I want it to go in a negative direction. So I'm going to drag that and I'm going to drop that to -18. Let's just do the complete opposite. Hopefully this works. All right. I'm not 100% sure because I'm not sure exactly the orientation of the motor. Okay. Now, before I go and test this, I want to name this particular program. So I'm going to come up here and I'm going to name this medium motor. Okay, so I think that's an appropriate name for this particular program. So now that I've done that, I'm ready to download this and see what happens. So here we go. Okay, so I've got my medium motor set up. I've got my program already downloaded. So we're going to test this out and see how this works. Okay, so the first thing that I want to do is I want to go to my second tab and I want to find my project folder. My project folder is medium motor project. I'm going to open that up and inside is medium motor. So I've got medium motor. And so once I run this program, I should see that this claw is moving up and down. So I'm going to press play and let's see what happens. Okay, went up, it should wait 3 seconds, and then it goes down. That's exactly what I expected it to do. Okay, let's run it one more time just to make sure everything is exactly how I wanted it to be. Up for 3 seconds and back down. No problem. It looks like a success to me. Okay, so we've tested out our robot and exactly what we expected to have happen did happen. So you've got an example of how to use the medium motor, and that was just simply using the basic robot that we've already built. Of course, there are other uses for the medium motor, such as making a claw or possibly driving a conveyor belt. But I do want you to understand that the differences between a medium motor and a large motor is that a large motor is going to have more torque, or it's going to have more rotational force. So those are going to be used to drive the entire robot, and a medium motor is going to be used for kind of like ancillary items for your robot, things that don't require a lot of force or rotational force. Now, when it comes to the speed of the turning of those motors, I'm not 100% sure, but I'm willing to guess that the large motors probably spin faster than the medium motor. Don't take my word for it. So that's the medium motor, not too much different than a large motor, not very complicated. All the options are pretty much the same. So with that said, I want you guys to remember, always use your brain, think it through and try to do the right thing, all right? So take it easy.
All right. Now you guys should have learned a bit more about how to program using the blocks we've gone over so far, the movement blocks, the turn blocks, and the wait blocks. Before we go back to our presentation, however, we're going to show a quick video about discovery in core values and how that's important. And this will be done by Julian. Thank you very much. And here we are.
Oh, what's this here I found? Search for clues and discover new ideas when you find a curious lead. Be the team that comes to the competition with a unique strategy.
All right. And now we are back to our presentation where we will be explaining the switch block, which is the second flow control block we're going to be going over. Once again, if you are paying attention, you'll notice that the block is no longer green, as the wait block was no longer green. It's orange. That's an important distinguishment to make so that you use the proper block when you begin programming. The switch block allows for a true/false statement based off of time in seconds or sensor input. The blocks can fit underneath the check mark or the X, as seen by my cursor, you should see that you can either fit blocks here or you can fit them under here. However, only one line of this switch block can be executed at once. So you can have up to 2 lines within this switch block, but only one can be running at once. Only the line that is, once again, some important things to remember. Only one line can be executed of the 2 available at a given time. And the switch block can be initiated when a sensor is pressed or even after a certain amount of time in seconds has passed. And now the next thing we're going to go over is, once again, a flow control block, but it's the loop block. The loop block allows code to be repeated for a certain number of seconds or when a sensor is alerted or pressed. This is also, once again, in the flow control category. It's orange, and make sure to be able to distinguish that. Some important things to remember about this block is that it can be configured to use primarily time or sensor values. An example of how this block can be used is that the loop block can loop the program for 10 seconds. Another example is that the loop block can loop the program when the ultrasonic sensor detects less than 4 centimeters, or even the loop block can loop the program when the ultrasonic sensor detects more than 4 centimeters. You can imagine a program running. You can have a loop statement in this, you can have a statement within this loop block that has your robot run until it sees less than 4 centimeters based off of the sensor input that you use within this loop block, which is really, really cool. So next we're going to go over the summary for flow control. And these are the 3 blocks we've just covered. Within flow control, some important things to remember about all of these is that each of the 3 blocks can be used, can be executed or incorporate time in seconds and sensor values, such as distance in centimeters. Additionally, these blocks will save you and your team time because instead of having to copy and paste your code, you could just use one of these blocks, repeat it for you. And finally, the most important thing to remember is that you should use these blocks with caution. This is where you and your team should double check your program the most often. Make sure to take your time and think about what you want to accomplish in your program and that you're doing it the right way. That won't result in your robot getting damaged or even your robot not functioning. And now the next thing we're going to go over, Victoria will be taking this from me. We have our 4 sensors.
Thank you, Ryan. So we're going to describe how to use sensors, but before that is the question of why we want to use the sensors in the first place. So when you make a program, you're telling the robot to perform specific tasks. For example, you could tell it to go straight for 3 rotations to maybe reach a black line on the mat where you want it to turn or complete a task. This method will work, but there are variables in the robot, environment, and situation which can add a margin of error to your program. An example of such a variable can be seen if you move the wheel of your robot back and forth. You will find that it can wiggle around without you turning the actual motor. Also, the game table could be slightly angled, or you could accidentally offset the program when you push the button on the brick. All these variables could affect your program, causing your robot to end up in slightly different places each time you run it. And the more steps your program goes through, the more these offsets will affect the end result. Does anyone have an idea of how you could solve this problem? What could you have the robot do that would make the program more accurate? Well, what if you told the robot, go straight until you reach a black line? This way, if the robot is held back, or if it gets too far ahead, it will still end in the same spot. In this solution, a color sensor is used to increase the accuracy and reliability of the program. Color sensors can also be used for finding areas of specific colors on the game mat, aligning to a line, or even following a line to a location. But of course, color sensors are not the only sensors that can help us improve our programs. Can anyone tell me 3 other of the main sensors? Anyone have any ideas? Okay, well, there's the touch sensor, the ultrasonic sensor, and the gyroscope sensor. The touch sensor senses touch. The ultrasonic sensor measures the distance between it and the object or surface in front of it. And finally, the gyroscope sensor reads degrees of rotation. These are all very helpful in making your programs accurate and reliable. When you analyze the field and consider the missions that you want to attempt, Think about which sensors can be used to help your robot perform these missions consistently. So you will notice that the block that we are showing here is yellow, whereas the first ones were green and then orange. The yellow blocks are the sensor blocks. I will note that the orange flow control blocks can be used for many programs that include sensors. They do not have to have the sensor blocks, but these are the ones that we are showing on the slide. So the touch sensor block works the same way as a light switch in your house. Once the red button on the touch sensor is pressed down, the sensor is on. On the other hand, when the red button has been released, the sensor is off. If you're taking notes, some important things to remember is that the touch sensor has 3 states: pressed, released, and bumped. With the pressed state, it notices that when you push down on the red button. This can be used when you're sensing for walls. That way, when the robot notices that it's been pressed down, it will proceed to turn or reverse, depending on how you program it. The bumped sensing can be very useful because it waits for you to press down on the button and let go of it, and then it acts on that input. So if you're starting a program by touching your touch sensor, this can be very useful because that way it'll wait for you to let go of it before the robot will start. That way your finger won't jolt the robot before the run. And finally, released means that it will wait for the red button to be let go of or released before it takes or uses that input. Another important thing to remember is that the touch sensor can be placed facing upwards on the robot. In this place, it'll be very good as a start or stop button for any of your programs.
And now to explain the touch sensor in a bit more detail, we're going to have another video of somebody walking us through the steps of coding it and then showing us a demonstration of how it works.
All right, hey guys, how's it going today? This is Mr. Zare from Landrum Middle School. Today we're going to take a look at a specific sensor that you have with your LEGO Mindstorms EV3 robot, and that is the touch sensor, or some people might call it a push button sensor, okay? And so we're going to figure out how we can use that, how we can program that, and I'm just going to go over some real basic things, and you guys are going to be creative and figure out other ways to use it. Before we do anything though, I want to remind you, make sure that you're always using your brain. Make sure you think things through. It's going to make life a whole lot easier. So what we have here is we've got my programming window completely open. I have a blank project, blank program. So I know that this project is going to be all about the touch sensor. So the first thing I want to do is just go ahead and save it. I'm going to save this project as, and my file name is going to be touch sensor, okay, project. And remember that a sensor is nothing more than an object that takes in information. Just like sensors for us are our sense of taste, smell, touch, sight. It's where we gather information. So sometimes our robots are going to gather information so they know what to do next. All right. So I'm going to save naming the program file for later, but we'll start with our start block. So we already have our start block. It's ready and ready to go. So we've gone through kind of our actions already. The most important actions we've gone over, the medium motor and large motor, and we're actually going to use the large motor as a way to test to make sure that our touch sensor is working correctly. So our touch sensor is actually going to be found in the flow control tab. And when we go to the flow control tab, we don't see a touch sensor, but the place that we're going to actually find it is in our wait programming block. So I'm going to drag the wait programming block up, and right now it's set for time. But if I click on the little clock here, I can expand and see all the other sensors and options that I have available to me. And the touch sensor is this one right here. Now, there are 2 different options for every sensor. There is always going to be a compare option and a change option. And this gets very confusing. And sometimes it's even difficult for me to explain it under certain circumstances. But we're just going to give a basic rule here. Anytime you use a compare option, what you are looking for is you're looking for a specific value to occur. Okay? And then for a change option, what you are looking for is you are looking for a change in the object or change in the sensor, and you set what that change should be, or we can consider a range. Now, in the case of the touch sensor, we are only going to use compare. If we use the change option, that would allow us to collect data, and we're not interested in doing that anytime soon, so let's not worry about that. So I'm going to go to the compare option, and we only have one option, and that is state. So I'm going to select that. Now, when it comes to the state, the compare state option, we've got that here. And then the very next thing is we've got the number 1. If I click on 1, I see 3 different possibilities. 0 is if we release the button, 1 is if we press the button, and 2 is if we bump the button. So in our case, most of the time, we're always going to use pressed as our option. So I'm going to make sure that that's 1. Now, I also want to take a look at my port and figure out exactly which port my touch sensor is plugged into. And it is plugged into 1. If I wanted to change it, I could change it to whatever port I'm looking for. Okay, and the way I want to write this program is I want the program to start, but nothing will happen until I press the button. Once I press the button, I'm going to want the robot to move forward, run 1 rotation, or actually, you know what? I want the robot to move forward forever until I press the button again. So I'm going to go back to my action tab, and I'm going to choose move steering, and I'm going to bring up the move steering block, and I'm going to turn it to on because I want it to run forever. And I'm going to have it run forward. Half speed is fine. My ports are B and C, and that's correct. So right now, the way I have this program set up, it's going to start, it's going to wait until I press the button. When I press the button, both motors will cause the robot to move forward forever. All right. Now, how do I get this thing to stop? Because right now this won't run because there's no stopping point. For me to get this to stop, I'm going to do the same exact thing. I'm going to bring up another wait block, and I want it to stop when I press the button again. So I'm going to hit touch sensor. I'm going to go to compare state, and I'm going to make sure that it's 1. And at that point, it should have something happen. And once I press that button again, I want the entire process to stop. So I'm going to make my move steering go to off. Okay. So again, we're going to wait for the push button. Once we press the button, motors will move forward until we press the button again. Motors will stop. Let's see how that works.
Okay, so we have our robot, we've already got our program, and we've saved our project on here. So what I'm going to do is I'm going to scroll to the right to the second tab, and I'm going to find the project that I just created, which is the touch sensor project. I'm going to open that up, and I realized in my haste, I forgot to name my program. So inside that folder, my program is just called program. So that's fine, but that would be something that I would need to fix later on. I'm going to scroll down and I'm going to select program. I've already got the program running. You can see that it's blinking, but nothing is happening. So I'm going to press the button and nothing happened. I wonder why that occurred. Okay, let's see if we run it again. Maybe I made a mistake. Press it, press the button, and boom, nothing has happened. My program has stopped. Let's go back to the computer and see if we can figure out what our issue is.
So here we are back at the computer, and there's 2 problems. Number 1, I forgot to name my program. So I'm going to go back and name that just touch sensor. Okay. And then we noticed that whenever I actually ran the program, there was an issue. It did not work correctly. Now, here's something that you need to be aware of about all types of programming. It runs in a very linear or straight line fashion. And for example, in this case, when I press this button, I cannot press the button fast enough for it to not think, oh, the button's being pressed. If the button's being pressed here and we're waiting for the button to be pressed here, what's going to happen is it's going to jump from this first programming block all the way to this programming block because I'm still pressing the button, right? So if I wanted to use the same button to start and stop, I have to create some sort of buffer or something to prevent it from jumping from one button press all the way to the next button press. Okay, so here's where we might want to use a wait time programming block. This is one way to do it. There are other ways to do it, but I'm just going to throw out this possible solution. I'm going to put in a wait time programming block. And, you know, maybe my finger is really slow. I can't press the button and release the button fast enough. So I'm going to make the time 2 seconds. So what should happen is I press the button, nothing happens for 2 seconds. The motors go forward and then it waits for me to press the button again. That 2 second delay should give me enough time to make sure that this thing works. So let's try this out, see if there's any improvement.
Okay, so we're back at this for try 2. Remember, we just added in that 2 second time delay to make sure that everything works out the way that we have planned it to work out. So I'm going to go to the second tab from my project folder. I'm going to find the touch sensor project folder. And this time, because I named it correctly, it's called touch sensor. I'm going to go down to touch sensor and I'm going to press it. And we can see that the project or the program is running. But now let's see if it works. I pressed it. There was a 2 second delay. Now the wheels are turning. How long will the wheels turn? Well, unfortunately, they will turn forever or until the battery finally goes out. So just so you can see, it is still running. So it's still running. The only way to stop this is press the button and now it's stopped. So the original behavior, although it made sense, required that time delay in order for it to work exactly the way that we wanted it. So let me just run that again just to make sure that we're clear. Nothing's happening. I'm going to press it. Then we're going to count to 2 before anything happens. 1, 2. Now it's moving. The only way to make it stop is to press the button again. And it stops. All right.
Okay, so now we're back at the computer again. It looks like everything that we planned and thought out worked the way that it was supposed to work. So what I just did was just show you one possible use for the touch sensor. We used it to start a process and to stop a process. We could also use it to stop a process and make something change and then continue. Like, for example, if your robot runs into the wall and it needs to turn 90 degrees and go in another direction, we can make it start a process while other processes are occurring. So we have 2 things running simultaneously. I'm going to leave all of that information up to you guys to figure it out. But now you kind of have an idea of how the basic function of the touch sensor works. So at this point, I just want you guys to remember, make sure that you're always using your brain. Make sure you think things through. And always, always, always try to do the right thing. You guys take it easy.
All right, I hope you guys learned a bit more about how to use the flow control blocks, the movement blocks, your motor blocks, and most importantly, the touch sensor. Next, to talk to us about the color sensor, Victoria, take it away.
Thank you, Ryan. The color sensor block can measure and compare both light and color. Additionally, it is important to calibrate your sensor before each robot run, since no 2 lighting situations are the same. You may be in the same room, but the sun has changed its position, or perhaps you go to a different place and now the lighting is completely different. So calibrating the sensor makes sure that it knows the environment that it's in when it runs so that it can perform well. If you're taking notes, it's important to remember that the color sensor can measure and compare both light intensity and color. Light intensity is the difference between black and white, the darks and lights. So it's helpful and useful when you're following a line, perhaps a black line with white borders or vice versa. Versus color can be used if you're looking for a specific spot on the mat that's maybe brown or red in color. Another thing to remember is that you always should place your color sensor face down so that it can measure the values from the table below your robot. And finally, always recalibrate your sensor before you use it. This should occur at the start of each program that your robot runs.
And we'll be going into more depth about how to reset your sensor before using it. Robert will do that specifically. But before we go on to our next type of sensor, we're going to receive a quick video from Julia about inclusion in core values and why that is important.
You too! All people have different weaknesses and strengths, but if we all work together, we'll go amazing lengths.
All right, and then we're back to our sensor. The next one we're going to go over is the ultrasonic sensor. Some important things to remember about the ultrasonic sensor. Well, just the general description first is that the ultrasonic sensor block can measure and compare distance in one of two different types of units. Most of you guys have probably heard of centimeters and inches. These are the two units that your ultrasonic sensor can measure and the ultrasonic sensor can measure between 4 centimeters and 225 centimeters in distance, which is quite a lot. The entire board, I believe, is definitely not 255 centimeters. So your ultrasonic sensor you can use it for pretty much any mission you need and not be limited by the distance, the max distance. Some important things to remember about the ultrasonic sensor is that it measures distance in centimeters or inches. To get an accurate reading with the ultrasonic sensor, it's always important that you place your ultrasonic sensor parallel to the ground. And we'll explain what that means in a second. I'm personally going to show my robot and how I've placed the color sensor, the touch sensor, and the ultrasonic sensor. And the final sensor we're going to go over is the the gyro sensor. The gyro sensor measures / compares angles or rates in degrees. This is the most complicated of the 4 blocks we've gone over, being that it measures a unit where you can't really tell. We can't really see as easily as we can tell distance. One of the important things to do with this block or with this motor, specifically in your code, is that you want to always calibrate it before using it. And this is to ensure that you and your team are as accurate as possible during your runs. Some important things to remember is that the most popular use for the gyro sensor is for measuring turns, both left and right, in degrees. And this could be measured in the value where turning right is positive 0 to 360 degrees, while turning left is negative 0 to negative 360 degrees. Additionally, it is recommended that you place your gyro sensor underneath your EV3 block in the middle of your robot, although it can be placed anywhere on your robot. Finally, always reset your sensor before using it. This should take place at the very beginning of your program. And now we're going to switch to my camera, and you'll see me in just a second. There I am. And I'm going to show you my robot, which is right here, and where I placed the robot or the sensors on this robot. So this is just the top looking down onto the robot, but looking on it dead ahead, you can see that the ultrasonic sensor is probably the first one you're going to notice, the 2 eyes. And as we mentioned earlier, you want to have that parallel to the floor. So if this is sitting flat, you can see that the ultrasonic sensor is looking dead ahead. It's not going to be veering up, or it's not going to be veering down. It's looking and measuring right in front of it. Secondly, we have the color sensor, which is this one. It's this one. This one's facing down, so they can measure the color, the different types of colors on the floor. It's very useful, and it works the best that way. And then finally, the most difficult one to see is probably going to be the gyro sensor, which is right here. This is, as we just mentioned, it should probably go in the middle of your robot, as it is here. Additionally, you probably should not scrape up against the ground. As you can see, it just barely hangs above the ground. It won't interfere with your runs in that it won't scrape on the ground. But yeah, once again, ultrasonic, you want to have parallel at the very front of your robot, typically. And then your color sensor, you want to have facing down wherever on your robot. And then your gyro sensor should probably be in the middle, tucked away safely. All right. And now we're going to go back to our presentation. Are there any questions about anything we've said so far? Okay. And this might, invoke some questions. We're going to have Robert's line following video utilizing the color sensor. We're going to show that to you guys and how he designed it. So really quick, I'm going to transition to his video, and this is just the demonstration of it. And then he'll explain how he programmed it and designed it. All right, next we have another video of him demonstrating how it's used. Sorry, just one second. Bam, that's the top-down view. And as you can see, it's directly following the black line in between the black and the white. It's doing this in a very, very professional manner. It's very, very impressive. And then from another view, we have it dead on, what it looks like, and it's very, very well done. And now Robert's going to give a quick explanation of how he coded it. And here that is now.
I'll be explaining my simple line following code. So what you need to know first as a programmer is whether the line is dark or light and whether the area around the line is dark or light. So for FLL, the area around the line is usually light and the line is usually dark. So we'll be going with that. The first thing the robot needs to know is the reflectivity of both of those. So what reflectivity is, how dark or light a material is. So if the reflectivity is low, that means the material is dark. If the reflectivity is high, that means it is light. So I've accomplished this via the color sensor as well as using this switch right here. So if the reflectivity is less than or equal to 10, then the robot will activate motor D, which on my robot is left. If it is greater than 10, then it will activate motor A, which on my robot is right. Now, what this will accomplish is a sort of shimmy down the line between the periphery of the line and the edge of the area around the line. Now, this all needs to be in a loop to work, which I have right here. This can be anything, but for my demonstration, I have it as 13 seconds.
All right, thank you, Robert, for explaining how to program the color sensor. So that is essentially the end of our presentation. Are there any questions about anything we said so far in regards to programming or core values?
Hi, I am Dr. V. I'm one of the coaches at Astro Park.
Hello.
Thank you guys so much. This was great. I just wanted to know how we can obtain the recording.
Of course. So that'll be sent to each coach in an email prior to this training. So all the resources that we used in the making of this presentation and the actual recording itself will be sent in an email not too soon after this presentation.
Okay, thank you so much.
Of course. Are there any other questions? All right. Well, thank you guys for attending. We appreciate it. And we're glad to see that there were a lot of attendance this time. We appreciate you guys. Hope you're staying safe during these trying times. And if there are no other questions, you are free to go. Thank you for coming.